Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so this problem is meant to test our knowledge of Ampere's law, or how well we understand it. So the setup that we have is we have the plane of page, which is the plane of, we can just say this is the plane, flat plane, this is a piece of paper, and we have a magnetic field perpendicular, so pointing out towards us from the plane. So this is a component of the magnetic field pointing out of the page. So we are told to show that there can be no current if there is a circle drawn in this plane. So the magnetic field is passing through this circle but perpendicular to it. Now, Ampere's law states that the sum of the magnetic fields that are parallel to the current multiplied by a small displacement in the loop, delta L, is equal to the permeability of free space, or the constant mu naught, times the current. So we want to show that there is no current in this situation. So what does this side mean, the left-hand side here? So now if we take this circle here, I'm going to make it a little bit bigger so we can see what's happening. And this doesn't have to be a perfect circle. This can be any shape. And if we take a small little segment here, so from, between these 2 points is our delta L. Delta L. And on this point specifically, we have one portion of the sum of the magnetic field. So if the magnetic field is pointing perpendicular to this plane, we would have to multiply by the parallel part of B, but if it's perpendicular, there is no parallel part. If this were parallel, it would have to be pointing in the same direction as this delta L. That's what it means. That's why they're taking small segments here. It's each segment. So at this point, if we were to go up to a different point in the circle, right here, our parallel B would have to be pointing in this direction. Either direction. It could be pointing down or up in this case, but it has to be parallel to the length of wire. In the case of it coming perpendicularly out of the page, it has no effect. So there is no parallel B multiplied by this delta L. We still have delta L. We can still move around this circle by taking delta L's by little piece, but there's no parallel magnetic field, which means this side is 0, which means this side also has to be equal to 0. And we know this is a constant. That doesn't change. So the only part on this side that has to be equal to 0 is the current. Current has to be equal to 0 because this B equals 0. There's no parallel component of the magnetic field. And that's the definition of Ampere's law here. This is what it tells you. And that's how you show that there is no current in this situation.